Good morning, everyone. So for today, we are focusing on cycle 2, day 8, and we will be looking at how to add and subtract, multiply and divide fractions, as well as reduce fractions and convert between mixed and improper fractions. Okay, but before we get started, what I would like to do with you all is just complete a quick entry card just to pretty much review what we've covered from day 7. So if we look at the handout right on my right side here, what we want to do is figure out what the slope is of each of the two lines given here. Then we want to discuss what it means in relation to the labeled axes. So in other words, remember from day 7 when we spoke about the relationship between slope and rate of change. Essentially, they are the exact same thing. The only difference or slight difference is that rate of change will include units, or the units that are being used within the graph. So the first thing what we're going to do is I'm just going to select 2 points along my line here and use our slope formula. So recall that the slope formula is m is equal to y2 minus y1 over x2 minus x1. So 2 points that I can see are 165 and 180. So I'm just going to write them here. So 165 and 180. And another point that I can see that falls right on my grid lines are is 125 and 110. So what we're going to do now is just input our 4 values into our formula. So y2 I'm just going to label as 180 minus 110. Divide that by 165 minus 125. Simplifying the top and bottom, we'll be left with 70 over 40, which equals 1.75. Now, because we are dealing with rate of change, okay, that's what it's asking us. What does it mean in relation to the labeled axes? In the situation here, what we want to say is, if we're comparing wrist circumference and height, what this is telling us is that, therefore, the wrist circumference, oops, I missed an E there, circumference increases by 1.75 millimeters for every centimeter increase in height. So in other words, our final answer for the units that we would include would be then 1.75 millimeters per centimeter. So that's the first one. The second example I have here is looking at women's 500-meter speed skating records. So we're going to do the exact same thing, use our slope formula. You could technically use rise over run here. I just find it easier to use coordinates, but up to you. Okay, so for the next one over here, 2 points that I can easily identify are this point right here, which is 1983 and 40. So 1983, 40. And another point that I can easily identify is directly at 2030. Oops, I can't see. 2037.5. So 2037.5. Sorry, I just need to grab my calculator. Okay, so again, we're going to use our slope formula. So m equals y2 minus y1 over x2 minus x1. Taking my y values, I'm going to take 40 minus 37.5 And now subtracting my x values in that same order, I'm going to take 1983 minus 2000. So simplifying this, we're now going to have 2.5 in my numerator and negative 17 in the denominator. So continuing to divide this, we're going to have 2.5 divided by negative 17, and that's going to leave us with negative 0.147. I'm just going to round off at that third decimal place there. So what this tells us, if we're comparing time versus the number of years, in this 500-meter speed skating records, we can say that for each year that passes, the time decreases by 0.147 seconds. Think about it this way: the more years that they are training for this, for these skating records, the more fast they will become. Okay, so in other words, for our units here, what we can just say is negative 0.147. So in other words, for our rate of change, you can say that it is negative 0.147 years per second. Oh, oops. Give me 1 second, guys. Sorry about that. You always want to write the dependent variable first, so the y-axis. So negative 0.147 seconds per year. Okay? So now that we are done with our entry card, what I would like you to do is to please, if you're able to, print off this next handout. If not, copying it down on a blank sheet of paper is perfectly fine. What we are going to do now is just complete this handout here. And this should technically be a review from way back the semester when we started looking at fractions in our review. Okay, so what we're going to do first is just illustrate the expression of 6 divided by 2 equals 3. So we're going to illustrate this by drawing 6 items and putting them into groups of 2. So let's just draw our 6 items here. So I'm going to draw 6 circles. So 1, 2, 3, 4, 5, 6. Now, if I were to divide 6 into 2 groups, essentially, so let's just divide these. So dividing my 6 circles into groups of 2. Okay. What's going to happen is, in total, I am going to have 3 groups of 2. So we have 3 groups of 2. So this is just an illustration that demonstrates what 6 divided by 2 actually looks like, okay? Now, I'm not going to ask you this in the future. This is just to, again, illustrate how these fractions work. Now, what about 6 divided by 1 over 2? We know that this equals 12, but again, let's just use an illustration for that. So the first thing I'm going to do is just draw 6 items. I'm just going to use squares in this case. So I have 1, 2, 3, 4, 5, and 6. So if I'm dividing by a half, what this means is that I am going to create groups that include only half of these items. So what I mean by that is I'm going to draw half, or draw a box around half of one of my one of the 6 purple boxes. So that's 1. I'm going to include another half below that. That's a second box. Drawing a third half around my next box. That's 3. Drawing another half. That's 4. Another half. You get the gist of it. So I'm just going to continue doing this without talking. Okay, so you notice now that once we've split up every single item here, pretty much into half. So notice the first box we split up into a half. What we are left with are 12 groups of halves, or halves in this case. So in other words, what we want to write here, so I'm just going to draw a little note at the bottom so you can remember why I did this. So 6 divided by a half equals 12, meaning that we are going to place items into groups with half an item, with half an item. So in total, what we've noticed here is that we have 12 groups of half. Okay? Which is exactly what the answer is when we divide 6 by 1 over 2. So I'm not going to ask you to illustrate fractions. Okay, again, this is just to make sure that we understand where our answers are technically coming from. So for the next part here, all it says is that we are taught in elementary school to multiply by the reciprocal. Remember what a reciprocal is. It's when you are, in other words, it's when you are flipping a fraction. Okay? How is multiplying by the reciprocal connected to our illustration above? So what we're going to do is, let's just rewrite the original question. So 6 divided by 1 over 2 is equal to 12. Let's work with just the left side here. So if I have 6 divided by 1 over 2, 6 divided by 1 over 2, what we would do is when dividing fractions, as mentioned before, what we want to do is take the reciprocal of the second fraction. So now what we're going to have is 6 times 2 over 1. Again, when multiplying fractions, this always has to be done when we are dividing. So now what we can do is simplify 2 over 1. 2 divided by 1 just equals 2. So now we're just going to be left with 6 times 2, which equals 12. So what we want to say here, and I'll use a different color, is that this is connected to the illustration above, because you have 6 items that are each split. Sorry, 1 minute, everyone. Yes? Okay, sorry about that. So what I wanted to say is, sorry, we have a few teachers in the household right now. So what I wanted to say is that this is connected to an illustration or to the illustration above because you have 6 items that are each split into 2. Therefore, you have a total of 6 times 2. So 6 items technically, because we have 6 boxes, and we're multiplying that by 2 each time, which equals 12. So on the back side here, what we're going to do is just express the following in lowest terms for the first one. So in order to express fractions into lowest term, what you would like to do is find a number that divides both into your numerator and denominator. So in other words, your greatest common factor. So for this case, both 3 and 6 can be divided by 3, which means that my fraction in lowest terms would be 1 over 2. 3 divided by 3 is 1, 6 divided by 3 is 2. Now, we want to now convert to an equivalent mixed number in lowest terms. So in order to convert to a mixed fraction, what you would want to do is check how many times can my denominator pretty much divide into the numerator. So in this case, we know that 2 divides into 5 only 2 times, right? 2 times 2 equals 4. So that means that our whole number, so that very first number for the mixed fraction would be 2, because 2 fits into 5 only 2 times. So if I were to take whatever is remaining now from that number, which would be the number 1, that would be placed at the top of my fraction. And your denominator is just going to be the exact same as the improper fraction. Okay? So for the next one here, how many times does 4 go into 7? Only 1 time. So 1 is going to represent the whole number. My denominator is going to remain as 4. Okay? So now if I were to think about how much is remaining, if I were to try to fit 4 into 7, we would say that the number 3 is remaining. If I would like to convert to a mixed fraction, this is quite simple. All you're going to do is take the whole number. You are now going to multiply that by the denominator and add the numerator. So in other words, if I take 1 times 4 and add 3, my denominator is still going to remain as 4, just like the previous fraction. And we're just going to use BEDMAS and simplify that. So 1 times 4, that's 4, plus 3, we have 7 over 4. And the very last one, if I want to state an equivalent fraction. So in other words, this very similar to proportions back from the Friday, I think, before March break. How do I get from 5 to 25? Well, it's simple. All we do is multiply by 5. What I do to the top of a fraction, I have to do to the bottom. So that means that I also need to multiply 10 by 5 as well. So therefore, 5 over 10 is going to equal 25 over 50, because 10 times 5 leaves us with 50. So now we're just going to do some practice at the bottom here. So when we are multiplying fractions, remember, all you're going to do is multiply the numerators together and multiply your denominators. So I'm going to take 3 times 5 at the top, and I'm also going to multiply 4 times negative 9. So 3 times 5 is 15, 4 times negative 9, that's negative 36. And now what we want to do is see if we can reduce this. So luckily, this reduces quite nicely to negative 5 over 12, because the number 3 divides both into the top and the bottom. Oh, one more thing I do want to mention. Please make sure that whenever you do have a negative in a fraction, even if it appears in the denominator, all this tells you is that the entire fraction is negative. So what I would like you to do is please move the negative in your final step to either the top of the fraction, so your numerator, or directly in front of the fraction. Okay, it's improper form if it is in the denominator. So the next one, if I'm multiplying a fraction by a whole number, remember our first step is to place -2 over 1. Now what we're doing is creating a fraction. So we're going to now multiply our numerators and denominators. So we're going to have -4 times -2, all divided by 3 times 1. Simplifying this, we're now going to have 8 in my numerator and 3 in the denominator. That is simplest form. We cannot further reduce that. All right. For the next fraction, we are dealing with division. So that means we need to take the reciprocal of the second fraction. So I'm going to have -2 over 5 times -7 over 6. This means that I'm going to now take -2 times -7, which is 14. 5 times 6, that is 30. This reduces to 7 over 15 because we can divide both 14 and 30 by 2. Okay, so for the next example, notice how we have a mixed fraction. Remember, anytime you're dealing with a mixed fraction, the easiest thing to do is just to convert it to an improper fraction. So the first thing I'm going to do is do that. So if I take -3, multiply that by 4, forget I said the -3 for now. When we are converting to an improper fraction, what you want to do is just leave the negative in front of the fraction for now. Forget that doesn't exist. You are only going to be working with strictly the numbers. So 3 times 4, that's 12, plus 1, that's 13. So our fraction is now just going to be -13 over 4. Okay? And just on the right side here, because we're dealing with a whole number, that does need to be placed over 1. So what we're going to be dealing with now is -13 over 4 divided by -5 over 1. Our next step, remember, we need to take the reciprocal, and now we're going to multiply the fractions. So I'm going to now have -13 over 4 times 1 over -5. Now since we're multiplying, we're going to multiply the numerators. So -13 times 1, that's -13. 4 times -5, that is -20. And since we are since we are technically dividing two negatives by each other, remember, dividing two negatives equals a positive. So our final answer should just be 13 over 20. For the next example, again, we are dealing with a mixed fraction. And this time we are also adding. So when we are adding or subtracting fractions, please remember to include a common denominator. Okay, so let's just write a little note at the bottom. When adding / subtracting fractions, you must find a common denominator. Okay, so for this example here, I have -3 over 5 plus, converting this to an improper fraction. 1 times 2, that's 2, plus 1, we have 3 over 2. So what we need to do in order to get our common denominator here, okay, our greatest common factor between 5 and 2, in this case, is 10. So what we can do here is, in order to get to that number of 10, we can multiply the first fraction, both by 2, the top and bottom, multiply the second fraction by 2, by 5. By 5. And this will allow us to now have a denominator of 10 for both fractions. So negative 3 times 2 is negative 6. 3 times 5, we're now dealing with the number 15. So now, since we are adding fractions, that means that our denominator is just going to remain as 10. We do not touch the denominator now. The only thing we are going to be adding are the numerators. So negative 6 plus 15, that's going to leave us with positive 9 over 10. We are almost finished. This is our second last example here. So we have negative 1 over 3. Negative 1 over negative 3 minus negative 2 over 5. First thing we need to notice is I have two negatives being divided again. That can be simplified to positive 1 over 3. Since I am also subtracting a negative, okay, integers and operations, remember, what we are going to do is when I'm subtracting a negative, that's the exact same thing as adding. So in this case, I now have 1 over 3 plus 2 over 5. So again, we do technically need that common denominator. In this case, it would be 15. So that means I need to multiply the top and bottom by 5 for the first fraction, multiply the second fraction by 3 at the top and bottom, and that's now going to leave me with a denominator of 15 for both fractions. My numerator is going to be 5 on the first fraction and 6 on the second fraction now. So adding our fractions, I'm now going to have 15 in my denominator, 5 plus 6, that is 11. So the very last example we have here, very first step, let's convert that mixed fraction to improper. So 1 times 4, that's 4, plus 1 is 5, so 5 over 4. Since I'm again, remember, since I have a negative included in this fraction here, this tells me that the entire fraction is negative. So it's the exact same thing as saying minus, bracket, negative 2 over 5. So again, just like what we did with f here, because I'm subtracting a negative, this means that I am adding 2 over 5. So 5 over 4 plus 2 over 5. And I'll even kind of circle that for you so you can see what I did there. So again, we still need a common denominator. In this case, it would be 20 because that's the greatest common factor for 4 and 5. So multiplying the first fraction by 5 both on the top and bottom, multiplying the second fraction by 4 at the top and bottom, we will now have a denominator of 20 for both fractions. The first fraction, I'd have 5 times 5, which is 25, 2 times 4, which is just 8. So 25 plus 8, that equals 33 over 20. And no, that cannot be reduced. So that is the end of today's lesson. I will post a few questions for the homework on our classroom as well, with a hard copy of the solutions for this. There are 2 handouts for the homework. They're 2 worksheets. If you want to, please complete as many questions as you like. However, you're only responsible to complete the questions that I ask you to do. Okay? Thank you, everyone, and I hope you have a great day.